Hi everyone, in this video I am going to solve a BJT example. Look at the circuits. If you look at the circuit, you will see that we apply input at the base side, take the output at the collector side. So this is common emitter BJT. Let's solve the question. In section A, beta force given as 200 and VB is given as 0.6 volt and thermal voltage is given as 26 millivolt. So section A says that find the collector current of the transistor IC for DC case, question point or bias point. Question point or bias point is the DC point, do not confuse your mind. So when I look at the circuit, the first thing I see that here V input is AC. In DC case, it is short circuited. So here 0 volt, base is 0 volt. If base is 0 volt, then VBE is 0.6 volts. So emitter voltage becomes minus 0.6 volts. Minus 0.6 volt. If emitter voltage is minus 0.6 volt and capacitors are open circuited for DC case, so I can write here minus 6 volt minus 2 volt divided by 0.7K equals I emitter current. This is Ohm's law. It is 1.4 volt divided by 0.7K, 2 milliampere, and it is approximately IC. Okay, we did section A, so now what is asked is find AC gain V output over VI. When we look at the circuit, I will take this again. In AC gain, remember, AC analysis, the capacitors are short circuited and DC voltage supplies will be grounded. So this resistor is short circuited in AC case. Also this DC voltage supply will be grounded and V base directly equals to VI. So in AC case, my circuit becomes like this. Here VI, emitter is grounded. Here collector, there is RC which is 3K. And that's it, guys. So for finding gain, we should know GM value, and GM equals IC over VT. And I know that IC is 2 milliampere and VT is given 26 millivolts. So this is approximately 80 millisiemens. So remember, what is this? I need the value of VI over V input, and it is directly, V output over VI, and it is directly equals to V output over V base. Remember the common emitter gain formula. Common emitter gain formula was V output over V base minus GM RC divided by 1 plus GM RE. Okay, this is in general case. But in this question, when you look at, there is no R source here. So R source is grounded. I mean emitter resistance. There is no emitter resistance, so emitter resistance is 0. This term cancels. So in this question, gain equals minus GM times RC. RC is what is outside of the output resistance, and in this case it is 3K. So V output over VI minus 80 millisiemens time 3K, it is approximately minus 240. So let's solve section C. For section C, for a second signal applied to the circuit as in the figure below, find the total V output. I am looking at the second signal applied to my circuit here. What is applied is, previously there was no V input 2, now there is V input 2. So what will change? Remember the superposition formula. Superposition formula says that if there is independent sources, I can take one active at a time and deactivate the others. And doing this for all of them, all the independent sources, at the end, I can add the effect of all of each other. I mean, we did find the gain without the V input in the circuit, so we thought as V input 2 was short circuited. This case we will think that V input 1 is short circuited. So my circuit becomes like this. V input 1 short circuited. Here's 3K in AC. In AC case. This time there is 0.7K and capacitor is short circuited. There is V input 2 and V output is here. So what is this? This is common base gain. What was common base gain formula? Common base gain formula was V output over V emitter equals GMRC over 1 plus GMRB divided by beta force. But in this question there is no RB resistance, base is grounded, so this GMRB over beta force cancels, gain directly equals GM times RC. So V emitter here equals V input 2, so V output over V input 2 equals 80 millisiemens times 3K, it is 220, but this time it is not minus, phase is not shifted 180 degree. So that's it guys. Find the total V output. So total V output becomes like this. V output equals 240 V input 2 minus V input 1. Because remember, here V output over V input 2 is 240, it is plus, and in V input 1 it is minus, so it's like this. Thank you for listening guys, see you at the next videos, take care of yourself, have a nice day.